Hello everyone, myself Hans. Today we are going to solve the problem of UPSC Maths optional question from topic curve in space. Question is given: find the curvature and torsion of the curve, and the curve is given x is equal to a cos t and y is equal to a sin t and z is equal to bt. UPSC asked in 2015 for Indian Forest Service. It is also important for Maths optional of UPSC. Let's solve the problem. Given curve is, this is given by x is equal to a cos t and y is equal to a sin t and z is equal to bt, and the position vector is given by this is r vector is equal to xi cap plus of yj cap plus of zk cap, and we have to put the value of x y z in the position vector. This becomes r vector is equal to, here we have to put x is equal to a cos t, this is a cos t I cap plus of a sin t j cap and plus of bt k cap. This is the position vector. In the given question, we have to calculate curvature and torsion. And first we have to know that the formula used, curvature is given by mod of dr upon dt into d2r upon dt square upon mod of dr upon dt का mod cube. This is the formula used for calculating the curvature, and we can also find torsion, and the torsion is given by tau is equal to mod of dr upon dt into d2r upon dt square into d3r upon dt cube mod, this is the vector, and upon, here we have to write this is dr upon dt into d2r upon dt square का mod square, and from here we have to calculate dr upon dt, d2r upon dt square, and also find d3r upon dt cube. First we have to find from here, this is dr upon dt differentiating with respect to t. Here a is constant, cos t differentiating with respect to t, this gives minus of sin t, this is minus of a sin t I cap, and here sin t differentiating with respect to t, this gives cos t j cap, and here bt differentiating with respect to t, this gives b of k cap. And further we have to find d2r upon dt square differentiating dr upon dt with respect to t, this gives d2r vector upon dt square, this gives, we have to differentiating here with respect to t, here minus of a is taking constant and sin t differentiating with respect to t, this gives cos t, and this is I cap, and here cos t differentiating with respect to t, this is minus of sin t, so we have to write here minus of a sin t j cap, and from here bk differentiating with respect to t, here not a coefficient of t, so we have to write here plus of 0 k cap. Further we have to calculate d3r vector upon d3 cube, again d2r upon dt square differentiating with respect to t, this gives, here minus of a is already present, and cos t differentiating with respect to t, this gives minus of sin t, and minus is already present, so I have to write here plus of sin t, a sin t I cap, and here minus of a sin t differentiating with respect to t, this gives cos t, and plus of 0 k cap. And further we have to find, first we have to calculate mod of dr upon dt. So we have to write here once again. We have to calculating mod of dr upon dt. This is given by under root of coefficient of ijk squaring. This is given by here. Coefficient of I is minus of a sin t squaring. This gives a square sin square t, and coefficient of j is here a cos t. On squaring, this gives a square cos square t, and the coefficient of k is b, so we have to write here b square, and from here this gives mod of dr upon dt vector is equal to, here we have to take a common from here a square is taking common, and the remaining is here sin square t plus of cos square t and plus of b square. And we know that from trigonometry sin square t plus cos square t is 1. So mod of dr vector upon dt is given by under root of a square plus b square, and we can also write here this is a square plus of b square to the power 1 by 2. And further we have to calculate dr upon dt into d2r upon dt square. So we have to calculate here dr vector upon dt into of d2r vector upon dt square, and this is given by in the determinant. This is I cap, and this is j cap, and this is k cap. This is k cap, and we have to put the value of coefficient of I j cap k in the given determinant. First we have to put the value of dr upon dt. Here coefficient of I cap is minus of a sin t, and for j this is a cos t, and for k cap this is b, and d2r upon dt square, here coefficient of I cap is minus of a cos t, and coefficient of j is minus of a sin t, and the coefficient of k is 0, and we have to solving this determinant. First we have to open with respect to I cap, taking this column is supposed to be eliminated, and we have to taking operation between j and k. From here, when we have to cross multiplication 0 with a cos t, this gives 0, and when we have to cross multiplication with b with minus of a sin t, when we cross multiplication of this side, taking minus, and minus is already present, so we have to write here plus of ab sin t. And further for j cap, this is minus of j cap. When taking for j cap, supposed to be this column is eliminated, and we have to take operation between I and k, and from here 0 multiply with a sin t, this gives 0, and b multiply with minus of a cos t. When we taking cross multiplication with this side, we have to take minus, and here minus is already present, so I have to write here plus of ab cos t. And further for k cap, when we have to solving for k cap, supposed to be this column is eliminated, and we have to take operation between I and j. From here we have to cross multiplication with minus of a sin t with minus of a sin t. This is given by a square sin square t, and when we have to take operation a cos t with minus of a cos t, when we have to take up cross multiplication with this side, we have to taking minus, and here minus is already present, so we have to write here plus of a square cos square t. Further we have to solve. This is given by ab sin t I cap, and here is minus of ab cos t, this is j cap, and from here we have to take common a square is taking common, in the remaining the bracket sin square t plus cos square t. We know that from trigonometry the value is 1, sin square t plus cos square t is 1, so remaining is here a square k cap. And further we have to find mod of dr upon dt into d2r vector upon dt square. This is the value of dr vector upon dt into d2r vector upon dt square. This is the value, and we have to take a mod of, once again we have to taking mod here, the coefficient of dr upon dt into d2r upon dt square, the coefficient of I is a k in right in the root or on squaring, the coefficient of I is ab sin t. This is written as a square into b square sin square t, and the coefficient of j is minus of ab cos theta. On squaring, this gives plus of a square into b square cos square t, and here the coefficient of k is a square, so we have to write here a की power 4, and further from here we have to take common from here once again, under root of, we have to taking a square, b square is taking common from here, a square into b square, then remaining is here sin square t plus of cos square t and plus of a to the power of 4, and we know that from trigonometry sin square t plus cos square t is 1, so we have to write here under root of a square into b square plus of a to the power of 4, and from here we can take a common from under root. This is a square is taking common, this is b square plus of a square, and a square is taking into outside. We can also write once again, this is written as a under root of a square plus of b square, and we can also write mod of dr vector upon dt into d2r upon dt square. This is given by a square plus of b square to the power 1 by 2. We have to write here once again, we have to write the value of, first we have to write the value of, once again we have to writing here, first we have to writing mod of dr upon dt, mod of dr upon dt, this is we have to calculate it, this is given by a square plus of b square to the power 1 by 2, and further we have to calculate the value of mod of dr upon dt into d2r upon dt square is given by, here we have to calculate a into under root a into a square plus of b square की power 1 by 2, and further we have to calculate dr upon dt into d2r upon dt square into d3r upon dt cube, and further we have to solving for this. Once again we have to solving here, we have to calculating dr vector upon dt into d2r vector upon dt square into d3r vector upon dt cube, and this is given by, in the determinant, this is I cap and this is j cap and this is k cap. We have to put the value, first we have to put the value of dr upon dt, this is given by minus of a sin t, and coefficient of j is a cos t, and coefficient of k is b, and for d2r upon dt square, here coefficient of I is minus of a cos t, and the coefficient of j is minus of a sin t, and the coefficient of k is 0, and for d3r upon dt cube, the coefficient of I is a sin t, and coefficient of j here is j. Coefficient of j is minus of a cos t, and the coefficient of k is 0. And we have to solving this determinant. We have to solving this gives. On first we have to open with the I cap. This is given by minus of a sin t. Minus of a sin t. We have to open. This is supposed to be, this column is eliminated, and we have to take operation between I and j and k. From here 0 multiply with a sin t gives 0, and 0 multiply with minus of a cos t, this is also 0, and this is I cap. And for j cap, when we are to solving for j cap, we can also write here once again, this is a cos t, and for j cap supposed to be this column is eliminated, we have to take operation between I and k, and this row is supposed to be eliminated, we have to multiply with 0 with a cos t, this gives 0, and 0 multiplied with a sin t, this gives also 0. And for k cap, when we have to solving for k cap, here this row and this column is supposed to be eliminated, here is b, and when we have to solving for this and this is eliminated, from here minus of a cos t multiplied with minus of a cos t, this gives a square cos square t. And when we have to take operation between a sin t multiplied with minus of a sin t, when we have to cross multiplication with these sides, we have to taking minus, and minus is already present, so we have to write plus of a square sin square t, and this is k cap. And further we have to solve, this gives 0 I cap, and this is once again we have to write 0 I cap minus, we can also write here once again, this is j cap, this is minus of 0 j cap, and from here we have to take common a square. When we have to taking a square is common, cos square t plus sin square t, from trigonometry we have to write 1, and the remaining is here plus of a square b into k cap, and we have to find dr upon dt into d2r upon dt square into d3r upon dt cube. We have to find the mod of this. This is the value. Once again we have to write here dr upon dt into d2r upon dt square into dt cube r upon d3r upon dt cube, and this is the value is 0 I cap minus of 0 j cap plus of a square b k cap, and we have to taking mod of this once again. When we have to finding mod of this, the coefficient of I j k is taken into the square root or squaring. Here the coefficient of I is 0 and j is also 0. So we have to consider only the coefficient of k cap, here a square b square. So we have to write here a to the power of 4 b square. And when we have to taking outside from the root, this gives a square b. This is the value of mod of dr upon dt into d2r upon dt square and d3r upon dt cube. And we have to put in the formula to find this the value of curvature and torsion. Once again we have to find, first we have to put in the curvature, we have to find curvature. This is given by mod of dr upon dt into d2r upon dt square. We have to calculating here, this is given by a, once again we have to a into a square plus of b square to the power of 1 by 2 upon here mod of dr upon dt. We have to calculating mod of dr upon dt. Here we have to find mod of cube. When we have to cubing the mod of dr upon dt. On cubing, this gives here a square plus of b square to the power 3 by 2. So we have to write here a square plus of b square to the power 3 by 2. And from here we have to cancel out the terms. A square plus b square to the power 3 by 2. To cancel out a square plus b square to the 1 by power 2. This gives a upon once again a square plus of b square. This is the value of curvature. And further we have to find the torsion. Here 1 by 2 plus of 1, this gives 3 by 2. 1 by 2 to 1 by 2 is eliminated. We have to only a square plus b square to the power 1 by 2. This is the curvature. And further we have to calculate, once again we have to calculating torsion once again. And the torsion is given by, this is tau is equal to here mod of dr upon dt into d2r upon dt square into d3r upon dt cube. We have to calculating here, we get a square into b upon here mod of dr upon dt into d2r upon dt square का mod का square. Here mod of dr upon dt into d2r upon dt square of mod. We have to finding, once again we have to calculating mod of dr upon dt into d2r upon dt square का whole square, mod of whole square. We have to squaring, this gives a square into a square plus of b square. When we have to squaring, this gives a square plus of b square. We have to putting here, this gives a square into a square plus of b square. And from here a square to a square is cancel out, and the remaining is here b upon a square plus of b square. This is the required solution of the given problem. Torsion is given by b upon a square plus of b square, and the curvature is given by a upon a square plus of b square. UPSC asked in 2015 from topic curved space. Thank you class, and thank you for watching.